Okay, ladies and gentlemen, lesson 2.2, we're going to discuss briefly some estimating with decimals. When you finish this section, hopefully we have a good grasp on estimating decimal sums, adding numbers together with decimals, differences, so subtraction, products, and quotients, so multiplication and division. And again, being able to estimate. You'll notice in this particular case, I highlighted estimating, which tells me, or should hopefully tell me and you, round things off. Make your life simpler. Round to numbers that give you an approximate answer but are easy to work with. Okay? And when we talk about those, we're talking generally about using compatible numbers. Numbers that are close to the given number, but that make estimation easier. And often used to complete mental mathematics. Now, a lot of times we can use this to check to see, is our answer to a problem reasonable? Okay, does it make sense? And so when we're talking about examples for using 86 and a half, it could be rounded to 87, or 35 and 1/10 could be rounded to 35. So, for example, okay, and we'll go through a few examples. Let's say I'm doing 86 and 9/10 plus 58 and 4/10, and I'm actually lining the decimals up and adding and carrying and all that stuff. Okay, and I get an answer. Now, does my answer make sense? Well, I can use estimation to check to see if my answer makes sense. So I'm going to go ahead, I'm going to round these two numbers off. So 86 and 9/10 is basically 87. I'm writing with a different mouse today, so it might be a little sloppier. 58 and 4/10 is basically 58. Okay, if we round to the nearest whole. And in this particular case, it's not too bad to add these together. 8 and 7 is 15. Again, I'm just lining up my decimals in my head here. 8 plus 6 is 14. So 145 is the approximate answer. So if I were to have done this out, hopefully my answer was around 145. If it was, it's a sensible answer. If it wasn't, I probably have a problem. And I need to go back and figure out why and fix it. Same thing in B. If I'm doing 10 and 3800ths minus 6 and 711ths, and I do it all out, the complete process, I might use estimation to check to see if my answer is reasonable. Well, 10 and 3800ths is basically 10. 6 and 711ths, well, that is basically 7. 10 minus 7 is 3. So my solution to this problem here better be somewhere around 3. If it's not somewhere around 3, I have an issue. Go back and check and, do a little problem solving, figure out why it's off. If it's around 3, it probably makes sense and is probably a pretty solid answer. Okay? Negative 24 and 687 thousandths. Well, that is basically a negative 25. Again, in this case, I'm rounding the nearest whole. 3 and 678 thousandths. Well, that is 4, or at least rounded to 4. So negative 25 and 4 is negative 21. Remember, using my rules, positive and a negative here, I have to subtract their values and go with the sign of the larger absolute value, which in this case is the 25. So if my answer, if my solution to this here was around negative 21, I have at least a reasonable answer. Negative 45 and 9800ths, well, that's basically negative 46. And over here we basically have 13, again rounding to the nearest whole. 6 minus 3 is 3. 4 minus 1 is 3. So my answer to this problem up here should be around 33. If it's not, I've got an issue. I need to go back and figure out why. Going on to multiplication and division. So these are guidelines for using compatible numbers in multiplication. First of all, round to numbers that are easy to multiply with. And for example, single-digit numbers tend to be easier to multiply with, or numbers that end in 5 and 0. Okay, they're not the only ones, but when dividing, round to numbers that are divisible without a remainder. Okay, so if you can keep these two rules in mind when multiplying and dividing, you will make your estimation lives a whole lot simpler. Alright, so 32 and 3500ths, well, For right now, I'm going to call it 32, although I may change my mind and change it even further if I want to. 7 and 89 hundredths, well, that is basically 8. Okay, well, single digit number, easy enough to multiply with. 8 times 2 is 16. 8 times 3 is 24, plus 1 is 25. So our answer here, this solution to this problem up here, better be somewhere around or approximately 256. If it's not, there's a problem. You need to go back and figure out why. What's the issue? Okay, so 36 and 6/10, it's basically 37, although 37 is not a good number to divide with, so I'm probably going to change this a little further. -8 here, yes, I'm definitely going to change it a little further because I am going to pick a number close to this that divides by -8 evenly, and that probably the easiest and closest one is 40. So instead of doing 37 divided by -8, I'm going to do 40 divided by -8, which is -5. Again, round off, round off, round off. -14.2, -14. Close enough. Times, well, 4 and 56 hundredths, well, that's basically 5. Again, multiplying by a single digit number, not too bad. 5 times 4 is 20. 5 times 1 is 5, and 2 is 7. So we're talking about approximately -70. Yeah, so if I multiplied these out by hand, doing all of the steps, and I wasn't around -70, I'd have a problem. -98.5 is basically 99. Oh, sorry, that wasn't a negative, it's just a positive. So 98.5 is about 99, divided by 11 and 56 hundredths, but I'm dividing into 99. I'm going to use 11 because I know that 99 divides evenly by 11. Yes, this rounds to 12 if we go to the nearest whole, but I'm going to be smart about it. 99 divides evenly by 11. I only want an estimation. So go ahead and round it off to something that's easy, that will divide evenly. 9. You're good. So, alright, so on a math test, this is an application, a student worked out the problem here, 55 and 9/10 divided by 6 and 2/10, and got the answer of 9/10. Use estimation to check whether the answer is reasonable. So in this case, I'm going to go ahead and write it out a different way. So they did it the longhand way. Did all the carrying and borrowing and multiplying and bringing down and all that stuff. We just want to check, is it a reasonable answer? Is 9/10, which even then, 9/10 is basically 1. Okay. Well, the first thing looking at this, I hope that we realize that 6.2 goes into 55 and 9/10 quite a few more times than 1. So without doing any work, I hope you realize that this is not a reasonable answer. Okay. So now let's go ahead and do this estimating and see what happens here. So 55.9, that's basically 56. Alright. And 6.2, well, that's basically 6. 56 divided by 6, well, and depending on how you want to do this here, probably, well, 6 times 9 is 54. So if I were to actually round this down to 54, 54 divided by 6 would be 9. Oops, 9. Here we go. So the answer should be somewhere around 9. Well, this kid got 9/10. So one of the things, we could even go just a little bit further even and go, alright, well, what do you think he did incorrectly? My guess here is he misplaced the decimal. Okay. He probably put the decimal in the wrong place doing the division, and that is my guess. Obviously, I don't have his work in front of me to make that specific answer, to verify it. But so anyway, I think that, as I recall, gets us, yes, to the end of this particular section. And so your job is to practice with estimations. And again, when you are doing this particular work, estimate, estimate, estimate. Do not, please do not do the longhand version. We'll get to plenty of practice on that later. So, all right, keep calm, solve your math problems. Good luck.